So, welcome to the AP Precalc Sign Charts and Q&A lecture hosted by me. So, About 5 Hive, this intro session was hosted by me and it's led by Lance. It's a volunteer student-run initiative with over 100 plus volunteers. And consider checking out 5hive.org for additional AP resources and practice exams. And if you want to apply, check out this document. And I will send the document at the end of the lecture. So last year's lecture stats are people who attended got a 98% passed and 73% got a 5. Oh, and the very small content for this lecture is if you have inequality and it's greater than, it's above the x-axis, and if it's less than, it's below the x-axis. And intervals are based on if the value is positive or negative between each interval. And key points that you put on your interval are zeros and vertical asymptotes, which will be the parts of your sign chart. So for this first one, try to solve it. I'll give you guys like 2 minutes to try solving this sign charts question. Polynomials. Is sign charts inequalities? Yeah. Sign charts are pretty much like another way to solve inequalities. So this is like a polynomial inequality. I'm gonna answer, remember? Okay. So yeah, I'll give until 3:04 in my time to try to solve this, because there's not that many sign charts questions in general. So, and these are more time-consuming type of questions. Can you take out x? You can't really take out x because that's your x-axis. So you can't really take out x. You have to factor. That's your goal, to factor. Your goal is to factor, and then no, you could do that. Your goal is to factor into like a set of like a plus b times like x plus b times like x plus c or something like that. You're gonna factor into something like that. That's your goal. And setting it equal to or whatever is 0. So yeah, that's the goal of sign charts. Okay. So the people that want to try solving it, have you guys tried to solve it, and would you like me to reveal the answer? Okay. Alright, if everyone's ready to reveal the answer, I'll wait like a minute or two. So. Alright, so I'll go over the answer now. So the first step is to set everything equal to 0. So we're gonna subtract 6 and subtract 5x. So we're gonna say 6x squared minus 5x minus 6 is less than or equal to 0. And if you remember from back here, if it's less than or equal to, so we're looking for values below the x-axis. So from there, we're going to factor this. And if you factored it, you should have gotten 2x minus 3 and 3x plus 2. It is less than or equal to 0. Did everyone get to this part? Can you break that part down to factoring? Sure. Alright. So this is my favorite way to factor. There's multiple ways to factor. So pretty much like the x in box method. And so pretty much you multiply the a and the c values. So it would be negative 36x squared and negative 5x. And so pretty much, what are two values that add up to this? That multiply to this value but add up to this value. Nine and 4, yep. So 9x and 4x. And those multiply, but we need one negative. So if we want it to be negative 5x, so we're going to put a negative in front of 9. Then we put negative 9x, 4x, negative 6, and 6x squared. So then 3x has to go here, 2x, 2x, and negative 3, which is your 2x minus 3 and 3x plus 2. And I put x here by accident. There's multiple ways to factor. This is just the one I learned in like Algebra 1. Do whichever factoring method works best for you. Slide and divide. Never heard that one. Just factor it. Yeah. So from there, you have to set up your sign chart. So from there, you put your line, number line. You're gonna set this equal to 0, which means 3 over 2 is one x-intercept, and negative 3 over 2 is your other x-intercept. So you're gonna put 3 over 2 and negative 2 over 3. And then from there, all you have to do is plug in values. So what if you plugged in 0, what would you get as your, it would be negative. If you plugged in the value 0, would the number be positive or negative? It would be negative. Yep, because if you plugged in 0 for the top, it would be 2. It would be 2 minus 3. Actually, it would be 0 minus 3. 0 minus 3 times 0 plus 2, which would be negative times positive, which is always negative. Then the next one, if you want to plug in a value on this side, what number can you plug in easily on this side? That's the left of negative 2 over 3. Negative 1, yep. So now you're going to plug in negative 1. So negative 1 would make it negative, negative, which would make it positive. And then finally, you're going to plug in a number on this side. What number can you plug on the right side? Okay, you could plug in 10. Okay, we'll plug in 10. So the first number would be positive because 20 times 3 would be positive. And then you would plug in another positive number, which means it would be positive. So we said it wants to be less than or equal to 0. So it has to be negative then. So we're saying our interval is between negative 2 over 3 to 3 over 2. Any questions about this? About how you solve sign charts? This is pretty much how you do every question. And yes, you could also use end behavior and degree of roots to find a solution, but there's multiple ways to do this. So any questions about this question? I just try out factors. Yeah, you could just try out factors. You could also just try plugging in numbers. Alright, next question. So try to solve this. I'll give like 4 minutes for this one. So until 3:13 and the time that's in the bottom right corner. Try and solve this. And then we'll have Q&A at the end for Unit 1 stuff after sign charts. Yeah, most schools don't teach Unit 4 AP Precalculus. It's usually just the Unit 1 stuff, which is like polynomials and rationals. Unit 2 is exponential logs. Unit 3 is trig and polar. And then Unit 4 is like a lot of random stuff. No, polar is part of Unit 3. It's not part of Unit 4. You will see polar on the AP exam, at least like a question or two about it. For future questions, would you want more time or less time for future questions? If you're stuck on factoring, Nimity gave a great hint. Rational root theorem, also known as polynomial division or synthetic division. Polynomial long division is how you solve it. That's how you solve this question. Less time for easier questions? Okay. Alright, then yeah, okay. Then we'll have less time from now on. Alright, so I'll give like until 3:12 to let people factor. More for harder, okay. Cool. Okay, so the first step would be to subtract the 6 to the other side. So we're going to have x to the 3 plus 4x squared plus x minus 6. And if you look at this, you can't factor by grouping. You can't factor a variable out. So you're going to have to use synthetic division. So synthetic division is pretty much you just test values of c divided by a. So you could test plus or minus 1, plus or minus 2, plus or minus 3, or plus or minus 6. We're going to test 1 first. So we're going to say 1. And then we put our coefficients. So 1, 4, 1, negative 6. Bring the first one down. Multiply. 5, 5. You add 6, 6, 0. So that means 1 works. So one of our factors is x minus 1. Now you do need to understand. That's polynomial long division. So it has to be factors of the constant. Yeah. No, constant over, it's factors of the constant divided by. So if it was like 2, right? If it was 6x squared, it would be, if it was 2x to the third, for example. If it was 2x to the third and then minus 6 is the last one, you could have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and you could divide each of them by 2. So you could have plus or minus 1/2 and plus or minus 3/2. So that's pretty much how you do that. How you getting the divisors? So pretty much you find the divisors by the c over a. So yeah, it's called c over a. So it's the formula is like c over a pretty much. So c is your constant and a is the value in front of your third, or in front of your biggest value. And you just have to do, so if we had 3x third plus 4x squared plus x plus 24, right? Is equals 0. We could do 24 over, we would have all the values of 24. So we have plus or minus 1, 2, 3, 4, 6, 8, 12, and then 24. But we also have all of them divided by 3. So we have plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 4 over 3, plus or minus 8 over 3. I'm finding roots. Oh. But you're gonna have to do it eventually. So you're gonna have to do it in calc, and you're gonna need it for some pre-calc questions, and especially teachers are gonna test it. So yeah, that's how you do this theorem. So anyone have any questions about how to find synthetic division roots before I erase this? The 1, 5, and 6. Oh yeah, so pretty much these are just so from here we have each of these terms. Now that we divided by x minus 1, we're gonna have this is our x squared term and this is our x term. So pretty much you just subtract one x exponent and go one down. So this was x there, now it's x squared, and so on. So now it would be x squared plus 5x plus 6 is greater than or equal to 0. And then I think you guys know how to factor x squared plus 5x plus 6. Which would be x plus 3, x plus 2. And then we're going to set up our sign chart. So we're going to have 1, negative 3, and negative 2. So let's plug in a number to the left of this. What's the number we can plug in to the left of negative 3? Negative 5. So negative 4 doesn't matter. So then negative 5, negative 4, it would make us a negative value, another negative value, and another negative value. Which means these two negatives cancel out, making it a negative value. Because two negatives make a positive, so then it's a negative value. Next one, between negative 3 and negative 2, what's the value we can plug in? Negative 2.5. So now the first value would be negative, our second value would be positive, and our second value would be negative. These two negatives would cancel out, making it a positive. For this one, what's the value we can plug in between negative 2 and 1? 0. So if we plug in negative, 0 would be negative, that would be 3, so that would be positive, and then positive again. So then there's a negative left, so it has to be negative. And then from here, you have 1. So what's the number to the right of 1? 10. Okay, so we're going to plug in 10, so that means the first one would be positive, positive, and positive, so it's going to be positive. And then from there, we want our interval, which would be, and we're saying it's going to be less than or equal to 0, so that means it's going to be the ones that are negative. So we're going to say it's negative infinity to negative 3, hard bracket, union, negative 2 to 1, union. Any questions? Yeah, you won't need these on the FRQs. You might need sign charts for the MCQs to like find the interval from like a set of questions, for a set of like options. You'll only see this on MCQs. You won't see it on the FRQs. So any questions about question number 2? Why the bracket instead of normal? So you don't use brackets because these values are included. So if it was less than, you would put parentheses or soft brackets, whatever your teacher called it. If you have a less than, if you have an equal sign under it, you have to include it, which are a hard bracket or a bracket. You have to write this in Set Builder? No. All the MCQs will just be like this. Set Builder doesn't exist for AP Pre-Calc, on the MCQs especially. But if you wanted to write in set builder, it would just be, I think, this. I'm not really good at writing it, but it would just be this. X is an element of between these two. If you want to include it in set builder. Do you have to draw the graph like the squiggly lines? Ignore these squiggly lines for now, but what do you mean squiggly lines? Like which, not the set notation squiggly lines. You don't need this. This is extra. That's set builder. For AP Precalc, you just need interval notation, or this box. You have to draw the graph. Oh no, you don't have to. You don't have to draw the graph. At least, oh yeah, you could if you need. You could. You don't have to really. But if you really want to, you can see this one's coming from a negative. So you know this is coming from negative. Then it goes positive, negative, and then goes back to being positive. So it looks something like this. Yeah, exactly. You want to draw it. The sign charts are just to save you time instead of plugging in each number and drawing. But we'll go to the next one now. Alright, so this one I will give about 3 minutes. Because it's a bit of a harder one. So 3:24. And in the meantime, I'll just answer any general questions. And like always, this lecture is recorded and should be on YouTube, on the 5 Have YouTube soon. You like this question? I'm glad you like the question. Does the website have all the APs? It does have most of the APs, but some of them aren't like completely done. Like bio has unit 1 done. Precalc has like articles like unit 2, like a few articles. Some unit 3 articles. It's like scattered articles. No course is fully done yet, but lectures are like the thing that are like will always be there. So yeah. There's also like resource documents in like both bio and precalc with like resources for you guys to use until like the entire website's done. And stats, yep, and stats. Stats, precalc, and bio all have resource documents. And in like maybe in like a month, stats, precalc and precalc and calc AB will have an updated version in about a month or two. Precalc unit 3 is going to be done soon. Okay, cool. Precalc unit 3 will be done by the time you guys. For this question, I would recommend not squaring both sides. I think that would make it a lot harder. Yeah, squaring both sides would mess up the domain. Okay, so I'm going to start solving this like slowly. So the first step is to set it up. So I'm going to say x minus 3 is greater than or equal to 0 because they're already multiplied. So you can split them into 2 factors. And then you can say the square root of x plus 1 is greater than or equal to 0. Is greater than or equal to 0. From there, we know x is going to be greater than or equal to 3. And our other value would be x plus 1 is greater than or equal to 0. Because remember, for a square root function, the domain is x plus 1 is greater than or equal to 0. So that means x is going to be greater than or equal to negative 1. From there, we're going to draw a little sign chart. It's going to be a smaller one this time, where we have negative 1 and 3. And we know it has to be greater than negative 1, so it has to be going this way. And we also know that x is equal to 3 also has to be greater. So now we're going to do some sign chart stuff. So we know we don't have to check a value on the left side because we already know it's going to be greater than that. So we're going to check a value in the middle. So we're going to test 0, which would be negative, positive, negative. It would be negative and positive, so it would be a negative. Okay, and if you, what number can we plug into the right of 3? 4, okay, so 4 in the original would be positive, positive, which should be positive. So that means this is included, so we know it's going to be 3 to infinity, union, and we also have to include negative 1. Because if we plugged in negative 1, we would get negative 4 times 0, which means negative 1 is, because 0 is greater than or equal to 0. So we have to include that. So we're just going to put negative 1 in hard brackets like this. There's no interval for it. So for AP pre-calc, you put it in interval notation. Yes. I'm pretty sure for calc, you also put it in interval notation. I haven't gotten to calc interval notations yet, so. So you could also use set notation, yeah. The set notation gets confusing eventually when you have tons of inequalities. But 0 above like the values. Yeah, that's how you do set notation. You would do, when you draw negative 1 in, no, you put in hard brackets because this is interval notation. There's no curly brackets in interval notation. So pretty much you include negative 1 because it's the value that makes 0 greater than or equal to 0. You could also put curly brackets, I guess, like this. But you wouldn't see both of them as an answer. You would see one or the other. Alright, next one. Alright, now we get a little word problem. You can use a calculator to find after you set up the quadratic. Curly brackets are only for x. Yeah. They can be for both for x and y, but yeah, you're given a range problem. Yeah. Let's try solving this question. This, I'll give it a little bit more. I'll give it until 3:30 because it's a word problem. You could use a calculator to find the roots. I don't think you can find the roots without a calculator, so. I guess you can use kinematics if you know the kinematics, but for the pre-calc students, use Desmos to find your roots. Yeah, it's in feet. It's in feet per second. Go ahead, do this question. It's the same idea. You just set up your inequality and then you're gonna put in Desmos. So the only step for this thing is just to set up the inequality. So we would first. So it says above the ground, so it means it has to be greater than. And it says more than, so it means it's not equal to. Then we have 112 on the other side. And then we have 96t. And then from there, you just use Desmos to find your interval of values. There's not much math for this question. This is just to read the question. You could try divide by 4, so then you would get 24t minus 4t squared divided by 28. Yeah. And then you could divide by 4 again. 7t minus t squared. Oh, it's 6t, my bad. 6t is 7. Then you could try factoring this if you wanted to. Minus 6, no, plus 6t. T minus 7 is greater than 0. You could t squared minus 6t plus 7 is less than 0. So equal to 0. And then you wouldn't be able to factor it anyway, so you don't have a way of factoring this. So you need Desmos or TI-84, where you would get 1.6 to 4.4. Any questions about this? Shouldn't there be a domain if it's less than? It's a domain. It's between 1.6 and 4.4. That's your domain. That's the answer. 1.6 to 4.4 is a time interval where it's more than 112 feet above the ground. Why isn't it in brackets? Because it's less than. It's greater than. So it's not an included value. The time interval is when the ball is more than 112 feet above the ground. And it would look something like this, is what your quadratic would look like. So let me pull up Desmos real quick and send the screenshot of what that look like. Okay. Meter. Okay, 1 point in seconds. It's in seconds, but so this is what our graph would look like. Make it bigger. This is what our graph would look like. It'll be in the AP Precalc playlist, I'm pretty sure. Most of my lectures go in there, except I think one is not there, but yeah, there's a 5 YouTube channel. Everything except one of my lectures are on there because it was like a Q&A session. So yeah. Alright, next one. So I'll give you until 3:30. I'll give you 2 minutes for this. Make sure you make sure to like and subscribe, share with your friends. Make the videos go viral, all that fun stuff. There's also TikToks. We also have a TikTok and Instagram. And yeah, we have a TikTok and Instagram as well. We might one day. If I get time to next summer, I'll put some Precalc shorts. So yeah, if you factored you would get x squared minus x minus 20. You would get x minus 5. X plus 4 is less than or equal to 0. View our sign chart at -4 and 5. -4 and 5. 5. We plugged in 0, we would get negative, positive, and positive, which means our interval would be -4 to 5. So next one. This involves a lot of factoring. Not much else. Is there a question where you have to flip the inequality? There might be. I think there might be one. If not, if you divide by a negative, you pretty much have to flip the inequality. That's pretty much the rule. If there's a negative, if you divide by -1, or multiply by -1, you flip the inequality. F of 1 would work. Are there absolute value inequalities? No, there are not. F of 1, I would say not to do that. There's an easier way to do it. So yeah, so the best way would be to factor. So my recommendation is there's one term you can factor out from this, which will make you can use you can factor then using static division after you factor. And I think this is the last polynomial one. Then we go to rationals, which are pretty much the same idea. You just have an extra new rule. Then fractional functions with asymptotes. Yeah, those are rational functions. So yeah, those are the inequalities that we're going to be talking about. You're just going to do inequalities with those fractional functions or rational functions. Alright, so the first step would be to factor out x squared. So we would get x squared, x to the third, plus 3x squared minus 8x plus 28. Oh, minus 24x plus 28 is greater than or equal to 0. Then we're going to use synthetic division. And our factors could be plus or 1, plus or 2, plus 3, no, plus 2, plus 4, plus 7, plus 14, and plus 28. And there's two ones we could do. There's one easy one, so we're going to do -7 first, which would be 1, 3, -24, 28. So we would go 1, then you would multiply, so -6, -7. They're just the fact. Yeah, these are all potential factors of 28. You just have you can go testing each one. I've done these, so I know which one to use. So you have to go and test each one until you find which one works. So this would be -4. This would be 28. This would be 4. This would be -28. And then you would get 0. So now this is x squared, x. So now you would have x squared times x plus 7 times x squared minus 4x plus 4. And now this is a perfect square, so we know this is x minus 2 squared, x plus 7, and x squared. And then from there, we pretty much make our sign chart. So we're gonna, you just put x plus, you put -7 as your divisor. Or x, yeah, you can use x plus 7. So if you're doing polynomial long division, it would be x plus 7, x to the third, plus 3x squared, minus 24x, plus 28. And then you would do, last year's very bare bones. Synthetic division is pretty much bare bones. You pretty much just you just set x plus 7 equal to 0, x is equal to -7, and you just sit and divide and multiply. Synthetic division only works with binomials, yes. You can do synthetic with larger degrees, yeah. You can just keep going. So now we're going to do our sign chart. So other ones you have to tediously do long division, yeah. So now we're going to do our sign chart. We're going to have 0, 2, and -7. So I'm going to plug in a number to -8. So if we do -8, we will get positive, negative, positive, which would mean a negative number. Then we can test like -1, so that would be positive, positive, positive. You test 1 now, so positive, positive, positive. And then you can test like 3, which should also just be positive, positive, positive. So this would be positive. So it's saying where it's less than or equal to 0 in both the original. So it'll be from negative infinity to negative 7, hard bracket or bracket, union 0, union 2. And we don't want to include these positive values. If I was to imagine the graph, so if you're trying to imagine the graph, it would look something like, this is our x and y axis. It would look something like this. It would bounce, bounce, and then it would go, it would go through first. It would bounce and then keep going like this. So it looks something like this. Is what your graph would something look like that. On the quadratic part, it will bounce. Yep. So at x squared, which is here, and there's also another bounce, I guess. So it would bounce one more time. So it would go up and then bounce again. So this is like 2. We said this is 2. It would bounce twice. And they're included because they're double roots. Not just 2, yeah. If any square to the positive number, so x squared, x fourth, x sixth, anything with a root that's to this term would always bounce. You can even go to x8, x10, x12, etc. So now we have, what do you call it? Rational inequalities. So I will give same amount of time, 343. This is a pretty easy one. How to solve these. You don't need 2 sign charts. You only need 1 now. You still need 1. Now you just have an extra step to include. You will always need 1 sign chart per equation. That would just make, no, don't do remainder. Alright, so the way you do these are you first factor, so the top would be x minus 3, x plus 2, divided by x minus 1 is less than or equal to 0. From there, you make our little sign chart. So we're going to put a 1, we're going to put a 3, and we're going to put a negative 2. We're going to mark this x minus 1 as a vertical asymptote, which means this value will never be included because you can never go to that point because there's a vertical asymptote in that function. So we're going to plug in a number first. We're going to do negative 3. If we plug in negative 3, it would be negative, 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 which means it will still be negative. Now we're going to plug in 0. 0 would be negative, negative, positive. So now it would be positive. Oh, you're saying like 1 minus x minus 1 like this. Is this what you've done before? Oh, okay. This is like just one more step. But when you get to it, you'll be ahead now. It'll be it's the same idea pretty much. You just combine my 2 sign charts into 1. Wow. Same idea though. I've never seen 2 sign charts into 1, but okay. And then you can test 2, which would be negative, positive, positive, which should be a negative. And then if you plug in 4 or 5 or 10, it would be positive, 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 which means it would be positive. Which means our interval, we're saying it's going to be less than or equal to 0. So we're going to say our interval is negative infinity, negative 2, hard bracket. And because we don't include 1, we're going to say it's a union 1, 3, hard bracket. Any questions about this? Can you please go to the graph? Sure. So the way you would graph this, actually, I'll just put it on this. So sign charts are easier than graphing it. But if you were going to graph it, you would have, first we draw our axis. We have an asymptote of 1. So we know we can't cross that. It's also top. Okay, so that's going to get, okay. So from there, you know there's a x-intercept at -2 and 3. And then from here, we know the x values go towards, from -2, they go towards -infinity. And so from here, we know these values are negative because they're from our sign chart. So no, we know it's going something like this. And these values is going towards the negative values, and this is going positive. So it's going something like this, I'd assume. You need y-intercept. Yeah, you can find the y-intercept by making x is equal to 0, which means this would be like 6. But you don't even need, if you're doing a sketch, you could just do it like this. You don't even need the y-intercept. Can I get it? So pretty much the way I did this is based off the sign chart. You can see this is going towards -infinity. So we know it's going to be going down. We know this is going positive towards 1. So that means they're going to be going up towards 1. Here, we know this is going towards -infinity. So we're going to go down. And we know this is going towards positive infinity. So we know it's going up. I am not doing that such big exponents. Okay. Next question. This is actually a tricky one. This took a while to solve. So I will give until 351. And no, you cannot cross multiply. Don't try that. It doesn't work. You can't cross multiply. It eliminates solutions. Not for every question. You only get Desmos for 12 questions, 12 MCQs, and usually regression MCQs. You don't get them for the non-calc MCQs. You could compare them, or you could. Oh yeah, true. You could compare the two sign charts, or you could just make them into one sign chart. Yeah, that's the easiest way. Subtract and set them greater than 0. So from that hint, it would be 5 x minus 3 minus 3 x plus 1 is greater than 0. That's your first step. Now use your sign charts and then type your answer in the chat and put sidebars on, put 2 of these like straight lines on both of your answers to put the, what do you call it? To spoiler it. Yeah. And there's 2 more questions after this, and then it's just open Q&A. This is Unit 1. There probably won't be a Unit 2 lecture until like end of October, maybe. And this is 1.6 and 1.8 and 9. 1.9, I guess. 1.6 and 1.9. Can we get a lecture on October 31st, 2 a.m.? No, I'm not taking a lecture at 2 a.m. No, I'm not. I don't think 5 Hive is going to be happy at all. Not even 5 Hive. I don't think the mods are going to be happy if they have to. I don't think they're going to be happy if they have to stay up and watch my lecture. Not Reese's. What if I subscribe to the both? I think both of them. Yeah, I don't like Reese's. I can spend one in the chat. That's the reason. So yeah. Not October 32nd. I'll host one. Yeah, I am. So I'll host another one sometime in October near the end of it for pre-calc again. I'll try to host one every month. Trust. But until then. Okay. So now I will go over this. So the first step is, so now you're gonna cross multiply to get the same base. So it'll be 5x plus 5 minus 3x plus 9 over x minus 3 x plus 1 is greater than or equal to 0. You would simplify that to be 2x plus 14 is x minus 3 x plus 1. From there, you're going to do 2x plus 7 x minus 3 x plus 1. From there, you're going to set up your sign chart. So we're going to set up a little sign chart. So it's going to be a little bit longer. We're going to have negative 7, 1, and 3. And 3. And we know this is our VA, and this is also our VA. So we can never include these values. And notice this is a less than sign. So that means we're not going to include any values anyway. So we're going to test the value to the left of negative 7. What's the value to the left of negative 7? To the left of negative 7? Negative 5 is not, yeah, negative 10. So that would make it positive, negative, 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 which would make a negative. Now we're going to test the number in between, which would be 0. So it would be positive, positive, negative, negative, which should be positive. From there, we're going to test another one between 1 and 3, which should be like 2, which should be positive, positive, negative, positive, which should be negative. And then we're going to test the number to the right, which should be 4, which should be positive, 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 which means positive. And we're looking for ones that are greater than or equal to 0. So we're going to be looking at negative 7 to 1, union 3 to infinity. And that's our answer. Any questions about this? It's great, and there's no equal. It's great. So any questions about this question? Okay, so there's no questions, so we will do this one now. I will just give the answer in about at 3:57. Actually, no, at 3:56 I'll give the answer, and then if there's anyone with questions, I'll like write out the complete thing. Mendel's theory of precalculus. No, that's not on this. That is found in AP Bio. It's not actually. It's not even found in this course or in any calculus course. They found it. So it's in a course called biology. So our answer for this one. Oh, it's several people typing all up. No, there isn't. No. Alright. So the answer for this would be negative infinity to negative 4 over 3, hard bracket, union, negative 1 to 2, hard bracket. Any questions? If there's questions, I'll solve it. If not, I won't solve it. Union just means and. So it's this interval and this interval. Oh, it means or? Okay, it means this interval or this interval. How do you get that? Okay, yeah, I can explain that. Alright, so first step is to factor into factored form. So we would factor and we would get 3x plus 4 and x minus 2 divided by x plus 1 is less than or equal to 0. And then from there, you would set up our sign charts. So we would say there's a value at 2, negative 1, and actually negative 1, yeah, negative 1, and negative 4 over 3. And then from there, we're going to plug in values. We're going to plug in a value to the left of it. What's the value left of negative 4 over 3? Negative 2. Yeah, negative 2. So it would be negative 2 would make it negative, 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 which should make it negative. Then we're going to test another value between negative 4 over 3 and negative 1. So that would be like negative 1.25. So yeah, negative 3 over 2. No, negative 3. Test to plug in a value here. It would be, we could plug in, hold up, let me find the value. That's negative 5 or 4 works. Yeah, that's the value. So then you plug in negative 5 or 4, which would make it, after you did it, it would be positive. Then you could test 0, which should be positive, negative, positive, which should make it negative. And then you could plug in 3, which should make it positive, 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 which should be positive. And then we want it to be less than or equal to 0, so we're going to say negative infinity to negative 4 over 3, hard bracket, union. And negative 1 is a vertical asymptote, so we can never include it. So we're going to say negative 1 to 2, hard bracket. And that's our answer. Any questions? We got better this time. That's the difference. We're holding Q&As and like extra stuff. We got better. That's it. Even Bio's holding one next week. And at those times, yeah, true. But see, it's like useful. It'll just be on the YouTube channel, so when people have questions, they don't have to wait for like every video to get uploaded. Of which like 4, yeah, true. But it's fine. It'll be on the YouTube. People can watch it. And it's like saving. Can a point on the asymptote be in a domain? A point can never be on the asymptote. An asymptote's a place, especially a horizontal asymptote. There can be no points on there. No values are included in that. Okay. And final question for today. And then it's just open Q&A. Nah, it's fine. It's no dumb questions, especially in math. Cleared some confusion up. You don't make that mistake next time. This is already factored for you, so it's a really easy sine charts question. It's an easy one to end it off. Okay, and the answer for this would be negative infinity to -4, hard bracket union, 3/2, infinity. Any questions? Any questions about this one? Okay, going once, going twice, and sold. So now we're gonna go over some commonly confused things up to this point of AP Precalculus. So a function increases if the y values increase from left to right, and a function decreases if the y values decrease from left to right. So this is increasing, this is decreasing, this is increasing, this is decreasing, this is increasing, and so on. So whenever you go up, whenever you're going up, it's increasing. Whenever you're going down, it's decreasing. Next thing, a table with nth differences. So if you have like a table and you go like 1, 2, 3, 1, 2. If it has 2 differences to have a constant rate of change, it's a quadratic. 3 differences, a cubic, etc. If you have a question about concavity, yeah, I'll answer them. Like if you have like specific questions. And then a whole is when a numerator and denominator have a factor that cancels out together. So if you have like x minus 2, x minus 3, and x minus 2, and they cancel out, that's a whole. And when they cancel out, you get the x-coordinate of the whole. To find the value, plug in the x-coordinate into the simplified equation. So in our case, you would plug in 2 into this, so our whole value would be 2, -1. And a revised rational function is pretty much when it's simplified and the whole is removed. And then the final thing is vertical asymptotes happen in the denominator of a rational function. Zeros of a rational function are in the numerator. And the horizontal asymptote rules are, it depends on the highest degree in the numerator and denominator. So if it's bottom heavy, it's the horizontal asymptote is y is equal to 0. If they're equal, it's the coefficients of the 2 highest degrees. And if the top is heavier than the bottom, it's an oblique or no asymptote. And that's pretty much it. And now it's Q&A portion. And here is the resources doc for anybody that is interested. And hold up 1 sec. So that's the end of the actual like science lecture. Now it's just Q&A. So I'm gonna end